Now, once we convert the entire matrix or the entire system into a triangular system using Gaussian elimination, then the problem is not solved yet because we want to find a solution for this system. The Gaussian elimination method only puts the matrix or the system in this format. Now we need to use something called backward substitution, because then from the bottom of the system, from the last row, we can then solve for x4, and once we get x4 we can solve for x3, and then once we have x4 and x3 we'll find x2 and so on. Now we can also put this in a loop, right? As an algorithm, we need to use a loop here to go from the bottom of the row of the matrix or the system to the top. So a variable that goes from 4 to 1. Okay, 4, 3, 2, and 1. Notice that we, let's look at, for example, x2. x2 takes the right-hand side 3 here, and then we subtract this term right over here. When we move to the other side, it becomes plus. So we take that and subtract that, and then subtract this one. That's what this is doing here. 3 minus negative 0.333 minus negative 0.33 x4, and at the end we divide by this coefficient right here in order to get x2. Okay, so we can easily put that in the loop. So here, for example, we can convert, we have to have a loop that goes, for example, if you are in x2, it has to be a loop that goes from 3 to 4. If you're in x1, it has to be a loop that goes from 2 to 4. It's always the index that you are at plus 1 towards the end, which is 4 here in this case. Alright, so here we can simply put a loop here. 4, we use 4, we can use j, I guess, to go. Let's say let's use I to go from the bottom of the system n to 1, right? N is 4, and then it goes from 4 to 1. Okay, what do we do? Well, at each one we have to have a loop, let's put j, that goes from I plus 1, the index that you are plus 1. So here we have, if we're at x1, we need to go from 2 to 4. So it has to be I plus 1 to n. Okay. Now within each loop, and we need to subtract, right? We take the right-hand side and we subtract this term here, which is this coefficient times the variable x3 in this case, and then this coefficient times x4. So we can use the right hand side, let's call this b. Okay, this guy here, it's b1. Let's call this guy b2, this guy b3, and this guy b4. So here we have bi, right, because it goes from 4 to 1, and the variable I is doing that. So a variable a bi would be bi, and then we need to subtract these terms. So this term here is made of the coefficient and the variable. The coefficient is the coefficient a, and at the row I and column j, times the variable j. Okay. For example, if I is 2, like we're here, then j goes from 3 to 4. 3 to 4. So j, it has to be xj because it's x3 and then x4, and the coefficient of the x variable is a row I, which is row 2, and then column j, which is 3 and 4. So that gives us that subtraction. But remember that at the end, after we do all this subtraction here, we need to divide by the coefficient of x2 here. So then that would be right before we move on from the next to the next row. So let me squeeze a number here. I guess I can just put this down here. And then right here, before we move on to the next row, going from the bottom to the top, BI, we want that to be divided by the coefficient AII. Right? If I is 2, then it's the coefficient A22. If I is 3, it's the coefficient A33. If I is 4, it's the coefficient A44. Right. And that gives us the right-hand side. And that's the variable x that we want. So I can put that here. In fact, instead of bi here, we can simply put the xi. And that will give us the final answer of the variable xi.